Athletes often push their bodies to the limit, striving for peak performance in various conditions. From the scorching heat of deserts to the icy terrains of polar regions, they encounter environmental challenges that test their physical and mental fortitude. Whether it's a marathon in the Sahara Desert or a high-altitude climb in the Himalayas, understanding how the body responds to these extremes is crucial. These athletes become very familiar with the science of exercise physiology, which explores the body's intricate responses to physical exertion in different environments. By grasping these physiological adaptations, athletes can optimize their training, nutrition, and equipment choices, gaining a competitive edge in extreme conditions. A key element of exercise physiology is understanding thermoregulation, the body's ability to maintain a stable core temperature despite external temperatures. This balance is primarily achieved through 4 mechanisms: radiation, convection, conduction, and evaporation. Radiation involves the transfer of heat through infrared waves, like the sun warming our skin. Convection is the transfer of heat through the movement of fluids, such as the wind cooling our body. Conduction is the transfer of heat through direct contact, like touching a cold surface. Evaporation, the primary cooling mechanism during exercise, occurs when sweat on our skin transforms into vapor, taking heat away from the body. In extreme heat, the body increases blood flow to the skin to dissipate heat and initiates sweating to cool down through evaporation. However, prolonged exposure can lead to heat exhaustion or heat stroke, emphasizing the importance of hydration and appropriate clothing. In cold environments, the body reduces blood flow to the extremities to conserve core heat and initiates shivering to generate warmth through muscle contractions. Proper insulation with layers of clothing becomes critical to prevent hypothermia. At high altitudes, the lower air pressure reduces the amount of oxygen available, leading to altitude sickness. The body adapts by increasing red blood cell production to enhance oxygen carrying capacity, but this process takes time. Acclimatization is the process of gradually adapting to environmental stresses, allowing athletes to perform better in extreme conditions. For heat acclimatization, athletes gradually increase their training intensity and duration in hot environments, promoting earlier onset of sweating and improved cardiovascular efficiency. Cold acclimatization involves gradual exposure to colder temperatures, enhancing the body's ability to maintain core temperature and improve tolerance to cold. Altitude acclimatization typically involves spending time at progressively higher altitudes, allowing the body to produce more red blood cells and enhance oxygen absorption. The benefits of acclimatization are numerous. It improves exercise capacity in challenging environments, reduces the risk of heat-related illnesses, enhances tolerance to cold, and minimizes the effects of altitude sickness.